Hello and welcome back to the lecture on applied econometrics. So in this lecture we are going to talk about
autocorrelation, and in this lecture we are going to give an example of autocorrelation. Now before we actually start with an example, let's first start to understand what is the difference between correlation coefficient and autocorrelation coefficient. So correlation coefficient we are already familiar with, and we'll see autocorrelation coefficient is just the same representation but with a little difference. Correlation coefficient and autocorrelation coefficient. Sometimes we know autocorrelation coefficient as autocorrelation function. Autocorrelation function is represented as ACF, that is commonly known. ACF. Now we know, we are familiar with how to estimate correlation coefficient, and we write, let's say for two uh, variables x and y, we write it covariance xy on the numerator, and in the denominator we have sigma x and sigma y, right? Now similarly, autocorrelation coefficient is just the same, but here we have, remember when we are talking about correlation, autocorrelation, it is always correlation with self, right? So it has to be correlation of the same variable with itself, but for different time period, right? So if I have xt, or let us maintain the consistency, we have yt, so it has to be with yt prime, let's say. And then in the denominator, since we are talking about the same variable, y, so then it is going to be sigma square y, let's say. Here my variable under consideration is y, so it has to be sigma square y. So that is basically the autocorrelation coefficient, and it depends, the value will depend between the difference that we take, t and t prime. So we'll just come to that. Now let's actually try to understand intuitively, to sort of understand what is autocorrelation, and let us actually draw something, okay? And let's say I want to understand the how the temperature is actually varying across the different months, okay? And here I have my, let's say it's not a really great straight line, let me draw it again. Yeah, much better. And let's say I have, oops, or let us actually just draw, doesn't matter. Okay, almost straight line. Okay, now let's so in my y-axis I have temperature, and here I have months. All right, so let's say in the month of January I'll start, and here let's say temperature is almost like zero. Let's say it's more than zero, but it's close to zero. I'm talking about India. Let's say in the month of February I'll have a little more temperature. In the month of March I'm going to have a little more temperature. In the month of April I'm going to have a little more temperature, a little more temperature. In the month of May I'm going to have quite a lot of temperature. It's going to be the summer, hot peak summer. June, let's say it is even more hot. But from July onward, because of monsoon and all, the temperature started declining. July, let's say August, a lot of rainfall and temperatures declining. September, let's say it's further down. October, it's down. November is down. December is close to zero. And January is again that. And February is again that. Okay. March, and this sort of cycle will be repeating, March, April. So this is, let me use a different color. This is my January, February, March, and let's say this is January 2021, and this is our January 2022. All right. Now, see the pattern here. Of course, there is a pattern. Now, I want to understand how I sort of measure the correlation coefficient, just I have seen for the to understand the autocorrelation part. Now, if I take, let's say, correlation coefficient between Jan and Feb, okay, so the temperatures are pretty close actually. Temperature is pretty close. So what I'll get is the correlation coefficient is going to be a little high, okay. But if I take Jan and March, if I take, so let me actually Jan and March. So it is going to give me a little less value of the correlation coefficient simply because simply because the temperatures are a little more different, right? Not as close as it was for Jan and Feb. And in fact, let me actually draw this. I'll have a different plot going on parallelly. So if I have, let's say this is the, if this axis is representing, let's say ACF, okay, autocorrelation function or the correlation coefficient for the measurement of autocorrelation, and this axis actually represents the lag. I'll just talk about lag, and let's say this is the differences in month, okay, differences in month, So here, so if I have Jan and Jan, if I measure Jan and Jan, so there is no difference. If I measure Jan and Feb, there is a one difference, so lag is 1. If there is a difference between Jan and March, so the difference is 2 months, so lag is 2. If there is a if you're measuring between Jan and April, so then there is a difference of 3, okay? So that way, and then Jan and May, it's a difference of 4. Jan and June, it's a difference of 5. Jan and July, it's 6. Jan and August is 7. September is 8. October is 9. November is 10. December is 11, okay? Now, so this is what is lag. So depending on when you are measuring, when you're using this formula, when you are taking this yt, and by the way, this is yt, this is not anything else, yt, this is just a comma, and yt prime. So the t prime, basically you see the difference between t and t prime. So if it is a difference of 1, which is if the month is Jan and Feb, then the difference is 1. So in that case, t prime is going to be t plus 1. Or if it is going to be, let's say, April, then t prime is going to be t plus 3, okay? So we're just trying to see, this is what is called lag, basically the time difference between these 2 points. And we're trying to see what will happen to the correlation coefficient because of the lag. Now, if I take, let's say, Jan with Jan, so basically the same month, same data, same everything, so then I will get a value of what? A value of 1. My correlation coefficient is going to be 1 for the very fact that I am basically taking correlation between 2 variables, the 2 same observations. So it is basically going to give me a value of 1. But when it goes to Feb, I'm going to have a little less correlation coefficient. When it's March, I'm going to have even less. April is going to be even less. May, even less. June, even less. And July, let's say July temperature is, let's say, increasing a little bit. August, let's say it is increasing a little bit. Or decreasing a little bit. September is decreasing a little bit. So again, it is coming close. October is, decreasing even more. November is decreasing even more. December it is decreasing even more. So the value is almost close to what we had here. And then again, so let's say Jan 2022, I have the same value, almost the same value. So it will be close to 1, okay? So it is basically, so this is for the month of Jan 2021. So I took the correlation coefficient. So here, let me use a different color. So Jan, or let me write JJ, JF, Jan, March. So Jan remains constant. Jan, April, Jan, May, Jan, June, Jan, July. Okay, so this way we can actually sort of see the impact of lag on the ACA, for the correlation that we get for the data, for the observations in different time periods. And this plot, this is actually a very important plot, and this plot is actually known as correlogram, CORRELOGRAM. So that's basically the idea of how we see a time series data, and how lag plays an important role when we look at time series data. So with this, we'll end this lecture, and in the next lecture we're actually going to see what happens because of the autocorrelation, consequences of autocorrelation. All right, and going forward we'll see how to actually address the problem of autocorrelation. Thank you.